We are going to be looking at increasing and decreasing functions as part of applications of differential calculus. We are going to start with increasing functions. We come up with a theorem using this graph, and we are going to be looking at two different examples under increasing functions. Then we are going to move into decreasing functions, come up with a theorem also, and we are going to be looking at two different examples also under decreasing functions. So on this graph, if you pick 2 points A and B, I pick point A and another point B, and we find the corresponding values of this on the x-axis. If I trace this to the x-axis and also this to the x-axis. On this graph, if we call this x, so we know that there's a change in x as x moves to the right of the graph. So we have a little change in x here, and we have this to be x plus dx. So from where you have the corresponding value of x on this first point A, to be this, and also the corresponding value of x plus dx on the y-axis to be this. So from this graph, we note that f of x plus dx is surely greater than f of x. So if you look at this f of x, and this is the corresponding value, and this is the x plus dx, and this is the corresponding value of y, and we know that this particular y is greater than this y. So we can draw out that f of x plus dx is greater than f of x. And if I bring f of x to the left hand side, I have f of x plus dx minus f of x is greater than 0. So having established this, we know that as dx is greater than 0, because the change here must be greater than 0 before we can move from x to x plus dx. So we know that the number dx is surely greater than 0. So once we know that dx is greater than 0, if I multiply the two sides of my equation by, if I divide the two sides of my equation by dx, if I now have f of x plus dx minus f of x divided by dx, this must surely be greater than 0, since I know that dx is greater than 0, and if I divide this by dx, I'm going to have the same thing, which is 0. So if you recall from differential calculus, we have that the limit as dx tends to 0 of f of x plus dx minus f of x divided by dx. So we know this from first principle, that this is the definition of dy over dx. So we know that this is the definition of dy over dx, and from what we have here, if I substitute this as dy over dx, I'm going to have that dy over dx is greater than 0. So we're able to get this from first principle. So just substituting this value here, we are going to have dy over dx greater than 0. So hence, whenever we have y equal to f of x, so this is going to be an increasing function if dy over dx is greater than 0. So here we are going to have an increasing function. So whenever dy over dx is greater than 0, we are going to have an increasing function. So if you are given an example and we are to look for the values which makes the equation to be increasing, we just have to look for dy over dx, then solve the inequality. When it's greater than 0, we find the values of x, and we're going to have the range which makes the equation to be an increasing function. So let's look at the first example. Find the ranges of values of x for which each of the following is increasing. Here we have two examples. The first one is to find the ranges of values of x for which x squared minus 4x is increasing. So I have my solution. So from our definition above, we have that for a function f of x to be increasing, dy over dx must be greater than 0. So the first task is to find the y of our dx. If y equal to x squared minus 4x, so finding the y of our dx, we're going to have the y of our dx equal to 2x minus 4. So by differentiation, I have the y of our dx to be equal to 2x minus 4. So for this to be an increasing function, we have that the y of our dx must be greater than 0. So therefore, from this question, I know that my dy of our dx is equal to 2x minus 4. So 2x minus 4 is greater than 0. So solving the inequality, I'm going to have 2x greater than 4. So and then I'm going to have x is greater than 4 divided by 2. And lastly, I have x is greater than 2. So for this particular function to be an increasing function, we are going to have x to be greater than 2. So whenever we have x greater than 2, so we have the function to be an increasing function. So let's look at the second example. So let me try to clean this place off to create more space. Okay. So in the second question, we have y to be equal to s to the power of 3 divided by 3 minus x squared over 2 minus 2x. And the question is the same, to find the values of x for which this function is increasing. So the first thing, as always, is to find the y over dx. So here I'm going to have the y over dx to be equal to 3x squared over 3 minus 2x over 2 minus x. So I'm going to have 3 cancel out, 2 cancel out, and lastly I have my dy over dx equals to x squared minus x. Sorry, this is 2 minus x minus 2. And if you study this very well, this is a quadratic expression, and we have to equate it to be greater than 0 for this function to be an increasing function. So we are going to have x squared minus x minus 2 is greater than 0. So solving inequality for a quadratic equation is a little bit tricky, but I'm going to walk us through a very simple approach to this. So if you factorize this, I'm going to have x plus 1 x minus 2 is greater than 0. So how do we solve this? So I'm going to go use the table method. So let me create a table here. And the first thing you have to do is to try to solve this first by assuming that you have it equated to 0. So if I have x plus 1 equal to 0, I'm going to have x equal to negative 1. And if I have x minus 2 equal to 0, I have x equal to 2. So I have negative 1 is the smallest and this is the highest. So I have x less than negative 1, negative 1 less than x less than 2, and then I will have x greater than 2. So this is an approach to solving simultaneous quadratic inequalities. So let me clean up this space also. So what I need to do is to try to bring all my factors in. So here if I have the first factor, which is x plus 1, so I have x plus 1a, and I'm going to have x minus 2a. So if this is your first time of solving quadratic inequalities, take note of this, and I'm going to have the product of x plus 1 and x minus 2, just like what I have here, x plus 1 multiplied by x minus 2. So the first thing you have to do is to pick a value, any number that satisfies the first inequality here, which is x less than minus 1. So we have this can be -2. So I can pick 1 here, and this I can pick 3. So these are the values that satisfy these inequalities. So the first I have x, I have -2, I have 1, and I have 3. So what I need to do is to substitute 3 and substitute -2 to this expression. So if I have -2 plus 1, I'm going to have -2 plus 1. So I have answer to be -1. So if the answer is negative, kindly put negative here. And here also substitute 1 into this expression. I'm going to have 1 plus 3, which is 1 plus 1, which is 2. So the answer is positive. And also substitute 3 into this expression. 3 plus 1, that is 4. The answer is positive. Also for the second expression, I'm going to try to substitute -2 to this expression. -2 minus -2, that is -4. So the answer is negative. Again, if I substitute 1 here, I'm going to have 1 minus 2, the answer is negative. And if I substitute 3 here, I'm going to have 3 minus 2, the answer is positive. So if I take the product of the first and the second expression, I'm going to have -1 multiplied by -1. This is positive. Positive multiplied by negative is going to be minus. Plus times plus is going to be plus. So I just have to circle out where I have my answers to be positive. So which is this and this in this case. So I'm going to have the solution to this inequality to be x less than -1 or x greater than 2. So I have the solution to be x less than -1 or x greater than 2. So this is an approach to solving some quadratic inequalities. So very quickly, let me try to graph this. If I have my graph here, so we have our first expression to be x less than -1. So if I have this to be -1 and also x greater than 2, this is +2. So anything in this end satisfy my expression, and I have s less than -1. So anything that falls here satisfy my expression. So I can just try to join the 2 points. That's not the perfect graph, but at least you're able to understand what it entails. So I have this to be my values, which makes the range of values which makes the function to be an increasing function. S less than -1 or x greater than 2. And I have the solution here. So that is simply how we can solve quadratic inequalities. So don't forget, we are trying to look for the values of y, for the values of x, which makes this function y equal to x cubed over 3 minus x over 2 minus 2x to be an increasing functions. And that's simply how we can approach increasing function. Don't forget, whenever a function is increasing, it means that the y over dx is greater than 0. So now let's look at decreasing functions. Again, to study decreasing functions, if you have 2 points, we are given a graph. And if you just pick any 2 random points on this particular curve, I pick this as point A, and I'm picking this as point B. So if I trace this to find the values of x for point A, so if I have this to be x and this to be point B, and there's a little difference in between point A and point B, a little change as changing x. So point B is going to be x plus changing x. So for point A, I have the corresponding value of y to be this, which is f of x. And for point B, I have the corresponding value of y, which is f of x plus dx. So from this graph, we're able to see that with a small change, as x moves to the right hand side, our value of y decreases. So we can have that f of x plus dx is less than f of x. And from here, if I bring f of x to the left hand side, I'm going to have f of x plus dx minus f of x is less than 0. And again, if I divide the two sides by changing x, so I'm going to have f of x plus dx minus f of x divided by dx is less than 0. So from the first example, we're able to see that from first principle, the limit as dx tends to 0 of f of x plus dx minus f of x, everything divided by dx, is defined as dy over dx. So if I substitute this to be equal to dy over dx, I'm going to have finally that dy over dx is less than 0. So coming from this expression, so for decreasing function, if you have a function y equal to f of x, so this is going to be a decreasing function in as much as dy over dx is less than 0, and this is the first was decreasing function. So we have that whenever dy over dx is less than 0, the function is a decreasing function. So recall that for the case of an increasing function, dy over dx was greater than 0. So let's look at two examples to illustrate decreasing functions. We also have two examples here, and we have to find the range of values of x for which each of the following is decreasing. The first one is x squared over 2 minus 4x plus 1. So if you have y to be equal to x squared over 2 minus 4x plus 1, I'm going to find the range of values of x for which the function y is decreasing. So the first thing we have to do, as always, is look for dy over dx. So for this expression, if we have dy over dx, so we are going to have 2x divided by 2 minus 4, and here we have 2 cancel out 2. I have dy over dx equal to x minus 4. And recall that for a function to be a decreasing function, dy over dx must be less than 0. So if I translate the same thing here, I'm going to have my dy over dx, which in this case equal to x minus 4 less than 0. I'm going to have x less than 4. So for this expression, x less than 4 will make the function y equal to x squared divided by 2 minus 4x plus 1 to be a decreasing function. So the second one, let me clean this up to have a more real estate to work with. Okay, yeah. In the second example, we have y to be equal to x cubed minus 5 over 2 x squared minus 2x plus 3. So again, the first thing we have to do here is to look for dy over dx. And in this case, we are going to have dy over dx equal to 3x squared minus 10x over 2 minus 2 plus 0. So here I'm going to have 2 here, and I'm going to have 2 goes in 10 in 5 places. So I have lastly that my dy over dx equal to 3x squared minus 5x minus 2. So again, I have to satisfy the condition that dy over dx is less than 0. So again, if I translate this here, I'm going to have my definition of dy over dx, which in this case is 3x squared minus 5x minus 2 less than 0. So now I'm left to solving this quadratic inequality. Again, the first thing I'm to do is to find the factors of this, and if I find the factors of this in a quadratic expression, I'm going to have it to be 3 x plus 1 and x minus 2 less than 0. So to solve this, as I explained in the first example, it's more trickish to solve quadratic inequality. So the first thing you have to do is to assume that you are equating them to 0. So 3x plus 1 x minus 2 equal to 0. So to solve this independently, I'm going to have the first case 3x plus 1 equal to 0, and then I have x equal to negative 1 over 3. And for the second factor, I have x minus 2 equal to 0, and I have here x to be equal to 2. So I have two answers. The first one, x equal to negative 1 over 3, and second one, x equal to 2. So again, I'm going to draw a table. So this is the smallest of the values. So I'm going to have x less than the smallest one, which is negative 1 over 3, and negative 1 over 3 less than x less than 2. This is the convention. So if you study this, how I wrote it in the first case also. So you pick the smallest one first, x less than the smallest one, then the smallest one less than x less than 2, and lastly x greater than the larger one, which is 2. And I'm going to pick my vectors. So the first factor is x, 3x plus 1. Second factor is x minus 2. So next thing is to pick a value for each of these ranges. So if I have x less than negative 1 over 3, I can just pick any value that will satisfy this inequality, and then I can pick negative 2. Just pick anything that is very close, and then I can pick 1 in this case, and I can pick 3 for this. So now is to substitute these values into the two factors and check whether you're going to have a negative or positive answer. So for the first one, if I substitute negative 2, I'm going to have 3 negative 2 plus 1, and this is negative 6 plus 1. I have negative. So again, if I substitute 1 into this, I have 3 times 1, which is 3. 3 plus 1, that is 4, and the answer is positive. So if I substitute 3, I have 3 times 3, that is 9. 9 plus 1, that is 10. So I have a positive answer. So again, if I substitute negative 2 into second factor, I have negative 2 minus 2. So I have minus 2 minus 2. That is negative 4. So I have a negative answer. So if I substitute 1, I have 1 minus 2. That is also negative. And if I substitute 3, 3 minus 2, that is positive. So if I multiply this, I have negative 1, negative times negative, that is positive. Here I have negative, and here I have positive. But recall that in the case of where we are trying to solve for answer which is greater than 0, we use the positive answers. So we use this and this. So that was in the first example, we use the positive result. But whenever we are looking at negative, we are looking at less than. So we are going to pick the negative answer. So we are going to pick this. So take note of that. Whenever you are solving for greater than, you are going to pick positive, and whenever you are solving for less than, you are going to pick negative. So in this case, I'm going to be picking negative, which is, so I now have my answer to this equation to be this. So I have my answer to be negative 1 over 3 less than x less than 2. So these are the range of value of x, which is going to make this function to be a decreasing function. So again, let me try to graph this so that we can better understand what we have. So I have 2, which is my positive number, and I have negative 1 over 3. So for this range, we have negative 1 over 3 less than x, so that is what falls towards the right hand side, and I have s less than 2, so that is everything that falls here. So to draw a graph of this, I'm just going to put this here. Oh, I want to get it better. Yes, so and everything that falls here satisfy this inequality. So I have for the expression y equal to x cube minus 5 over 2 x squared minus 2x plus 3. I have this particular expression to be decreasing if minus 1 over 3 less than x less than 2. So I have the range of values of x that makes this expression to be a decreasing function, and that is simply how we can calculate both for increasing and decreasing function as part of applications of differential calculus. If you have any question, feel free to drop them in the comment section below, and I'm going to reply to them as soon as possible. And if you find this tutorial interesting, don't forget to give it a thumbs up, a like, a share, and I'll be very happy if you can subscribe to the channel. It's very important for me. So thank you very much, and I'm going to see you in the next tutorial.